Okay, so if you're watching the addition reactions and you're now studying elimination reactions are actually just the complete opposite of addition reactions. So if addition means putting two things together, elimination means taking two things apart. So you might find that even the conditions are the same for some of the elimination reactions. For instance, here we're going to take some hydrogen off a saturated molecule. Now, if you remember from last time, a saturated molecule is something which can't take any more hydrogen. It is completely full. So I call something which has got single bonds, I call this a saturated molecule. Okay, so this molecule is saturated at the moment. Each one of these carbon atoms I'm talking about, they cannot hold any more hydrogen. So what happens is platinum is really good at moving hydrogen onto and off of things. So what we're going to do now is we're going to see what happens when we move those two hydrogens off these. Okay, so now I've got the two hydrogen atoms now disconnected from the carbon atoms, but there's some stuff that's missing. Each one of these hydrogen atoms still needs to bond to something, and that means that they need to make a single bond to something. So now they're going to bond to one another. You'll notice that the carbon atoms have each got 3 bonds, so we need to restore that to 4 bonds by making a double bond. Now, if you look very carefully, you'll notice that our product is unsaturated. That means that it's still got space for more hydrogens because we've just taken some off. So unsaturated means that it is not completely filled up with hydrogen. So elimination reactions, one of the ways that you can figure out that you've done an elimination reaction is that you've gone from very few products, in this case one product. So we've got that one saturated product over there. That's one of the giveaways. So we start with a saturated product, and that at the end we've got more chemicals, and one of the organic chemicals inside those products is going to be unsaturated. That's a dead giveaway that you've done an elimination reaction. You'll notice that most of the elimination reactions as well have got heat as a necessary consideration or condition, because you're actually taking molecules and breaking them up. You're not boiling them. You're actually breaking chemical bonds inside them, and you need a little bit of energy to break chemical bonds, if you remember from your energy and chemical change section. Okay, cool. So we have now taken hydrogen off something. So what do I call this type of elimination reaction? It's actually pretty easy. I want you to think about it for a second, and here's a hint. Start thinking about your addition reactions and seeing if you can understand what the addition of hydrogen was. So if you undo it, I want you to think about the name, and now's a good time to pause this video. Okay, so there it is, dehydrogenation. So the addition of hydrogen is called hydrogenation, but this little prefix of D means un, or against, or the anti of. So this is unhydrogenating. So hydrogen is the chemical that I'm taking off, so dehydrogenation is the elimination of hydrogen. Okay, there's a couple of types of elimination reactions, so I'm going to take you through a couple of them. So, make sure that you're making notes all the way through, and we're going to move on to the next slide. Okay, there we are. Now we've got this compound. This is bromoethane. I want you to practice your naming as you go. And now I'm going to subject bromoethane to some heat. So let's do exactly that. So we've got a little bit of an arrow there, and we're going to subject it to some heat. Now, if you heat up bromoethane in the right conditions, you can actually get elimination to happen. I've highlighted the things which you're going to eliminate, and those are in green over there. So there we go, HBr, and that's what's going to come off. I want you to see if you can predict the product. I want you to think about what happens when I take HBr off. So if H and Br are now bonded together, what's left behind? If you're following your pattern from your previous one, and organic chemistry is all about patterns, you'll notice that we've got the restoration of a double bond. Okay, so that's pretty important. We've made a double bond behind them. And don't forget the hydrogen down at the bottom. Those are pretty important as well. And now we've done an elimination reaction. And this was pretty easy. We started off from a saturated molecule over there. Look, the single bonds between them. And now we've made a double bond in the products. Now, what do we call this horrible beast of a reaction? Now, this is going to be the longest chemical process name that I need you to know, but we can figure out an easy way to remember it. We've taken off a hydrogen, and we've taken off a halogen. So remember, when you do elimination, it's D something. So what are we taking off? We're taking off a hydrohalogen. So this is dehydrohalogenation. And I know that that's a serious mouthful, so what I'm going to do is I'm going to put it up on the screen for you to write it down. Okay, so there we have it, dehydrohalogenation. So let me just go through the parts of this word to make it a little bit easier to remember. D means I'm taking something away, that's an elimination reaction. Hydro, so that's a hydrogen, and a halogen, which is the bromine. So we're taking off a hydrogen and a halogen, so we are taking them off. This is dehydrohalogenation. But there's a real problem with this reaction, because elimination is really difficult, and addition is really, really easy. So what's to stop HBr from going back and doing addition? So, I mean, what is to stop the HBr from breaking the double bond and going backwards? So how do we stop that from happening? How do scientists try and stop this from happening? Okay, and here's the way that they do this. The way that they can do this is they can put something to take away the HBr. The HBr is the problem, because HBr can always join back and go onto there. So what we're going to do is we're going to add something which reacts with HBr. Now, if you're very clever and you remember that HBr is bromic acid, it's not one of those that you have to memorize, but you know, hydrogen joined onto something is an acid, right? So if you can get something to clean up the HBr before it goes backwards, we can be left with our beautiful clean ethene, which is a very handy chemical. So how could we do this? Now, very often in your textbook, you'll actually find that you don't see the HBr as a product. Very often what you'll see is that we've still got our reaction over there, so we've still got our, I think that's bromoethane, yeah, that's bromoethane. So let's just draw that again, so we've got bromoethane again. But now you'll actually see another chemical which we add, which is designed just to clean up the HBr. And let's put in the HBr over there. So what could react with HBr, which is an acid? And I'm hoping inside your head you're telling me that it's going to be a base. So what I'm going to do is I'm going to put the base in another color over here. So I'm going to say plus NaOH, sodium hydroxide. Okay, once again you need a little bit of heat to do elimination reactions, and that's pretty important. So what we're going to do is we're going to subject this to a little bit of heat. Now, I just want to emphasize something. NaOH is not a catalyst. It's actually a reactant. So what happens is you're still going to make your unsaturated compound. There it is. But now, instead of producing HBr, you're going to produce a product of an acid and a base, which is a salt plus some water. Okay, so let me actually show you where everything goes. Okay, so we've got a salt, which is Na. So there's the sodium from the left, the Br. There's the salt. What else do we produce? We produce some water. The H from the HBr combines with the OH, and there we go, some water. So you've actually still got more products than you started off with. Now, the way that you can spot that this is still an elimination reaction is we're producing an unsaturated product. There it is. So an unsaturated product. And also we've got more products than we started off with. We've gone from 2 to 3. That's pretty important. Okay, what other types of elimination can we get? Well, if we can take off a hydrohalogen, we can take off anything that we can add. Now, in high school chemistry, I've never seen a dehalogenation, so we're not going to cover that. But what we can do is we can take an alcohol, and we can take that and take some water off it, because remember that you can make alcohols by hydrating an alkene. So let's do exactly that. Okay, so now let's start off from a very, very simple alcohol. We're going to start off with drinking alcohol, that's ethanol. And I hope you're not too familiar with this molecule. There we go. So some drinking ethanol. Now I'm going to draw it in a very weird way because I want to show you something. I'm going to draw the parts that are going to eliminate on the carbons next to each other. They always are. You're always going to find that you take something off the one carbon and something off the next carbon. So I mean, you need to take something off each carbon. So you can't eliminate that OH and that H. That's not where you can get water from. You need to take something off the one carbon. Then off the adjacent carbon, you take the OH. So we're going to take HOH, which is better known to you as water. Okay, so we're going to take some water off. Okay, once again, we need to apply a little bit of heat. But in this case, there's a catalyst, and you might remember that H2SO4 is our friend when we're trying to get water onto and off something. What's left behind is this beautiful double bond, and there we go. Okay, so that doesn't seem too difficult. Let's name this type of reaction, and if the addition of water was called hydration, if you add something, well, it's D something. So it's dehydration. Now that's a word that you've probably heard before. So let me put that up on the screen for you. And there we have it. So dehydration. That's a removal of water. Now you see there's a problem. It's very difficult to mop up water. One of the best ways that you can actually do this is you supply enough heat that it actually turns the water into steam, and you collect the steam separately in a condenser of some sort, and the ethene gas is allowed to escape before the two have a chance to combine again in an addition reaction. But as with everything, I get a question asked in class, is this the most complex way that we could do things? Unfortunately not. There are always options. So what I'm going to do is I'm going to draw a slightly more complex molecule and ask you to figure out the products of this dehydration reaction. And let me do this on a new slide, and then you can try and figure out what's going on over here. Okay, so now what I'm going to do is I'm going to give you something slightly confusing. So 1, 2, 3, 4 carbons. So I'm pretty sure you figured out that that's bute, and this is a butane base. And what we're going to do is I'm going to give you something intentionally horrible. I'm going to give you an OH in the middle. And what we're actually going to do is I'm going to change colors a little bit for a second. Okay, so I'm going to have a color-coded hydrogen over there, and I'm going to have a color-coded hydrogen over there, just to mix things up. Okay, so at the moment I've just got a really colorful butan-2-ol. So this is 2-butanol, which is on your screen. Now, if you start to do elimination off this, and if you get a little bit smarter than you already are, and that's the point of these videos, you'll see that there's actually two possibilities. There's a possibility that I could eliminate the water over there across those 2 carbons, or I could eliminate the water across these 2. Now I want you to stop the video for a second and try and draw the products. It's always good to try draw the products because you're going to make 2 separate products. Now this is not uncommon. We've seen this with addition reactions before, and you've got a major and a minor product. There's actually more of one than the other. So again, we've got 2 possibilities. I've got the one product and I've got the other product. Both of them are facilitated by H2SO4, which is pretty handy. And I want you to try to figure out which product is which one will be major and which one will be minor. Now the rules for this, this is called Zaitsev's rule, but you'll never be examined on it. It's pretty much the same as Makovnikov's rule if you've just been watching the addition. So what I'm going to do is I'm going to draw the 2 products, and we're going to figure out which one is the major and which one is the minor. Okay, so here's our first product. Let's take a look at what actually happened. Now in this first product, I've chosen to remove that, and I've left behind the other hydrogen, which is blue. So I've eliminated the red-green combo to put a double bond in the middle there. Now this is going to be one of the products that you form. I want you to start thinking about the product that forms when I take the blue and the red off. So I'm going to draw that for a moment, and I want you to do the same. Guys, you can't just watch this stuff. You need to practice. You need to draw. You need to name. Make sure that you can do all these things. Okay, so strictly speaking, I haven't drawn this correctly, but I just want to show you a point here. The ones which I've taken off now are the red and the blue combination, so there they are. There's my water molecule. The H doesn't actually join on with the H, but I just wanted to keep them in the same order to show you a point. So we've made but1ene over here, and that's opposed to but2ene. So which one of these is the major and which one of these is the minor product? Now, Zaitsev's rule basically says that double bonds really enjoy company. What that means is that double bonds actually prefer to be in the middle of a chain, because take a look, this carbon is joined onto 2 other carbons. That makes this into a secondary carbon. So that's a secondary carbon. And this is also a secondary carbon. It's joined to 2 other carbons. Now look at the bottom one. We do have a secondary carbon, but we've got a primary carbon, which means that it's only joined to 1. Double bonds love company. They love popularity. So double bonds prefer to be on two secondary carbons rather than a secondary and a primary carbon. So what you'll find is that, the top product is actually our major product. Double bonds prefer to form between two secondaries rather than a primary and a secondary. So I've got a major and a minor product. Now, it's quite possible that in an exam you might find that I or another examiner might just ask you for a major product. So all you've got to do if you ask for the major product is to draw the most likely one to form. Again, dehydration, very, very simple. We've got to do this at very high temperature to drive the water away, make sure that it doesn't re-add. Otherwise, you're going to get a lot of problems. Okay, so in terms of elimination, I want you to study elimination and addition together. They go hand in hand.